Hello everyone, welcome to Grade Up and welcome to another class of General Science for EPFO. And today's class we're going to deal with a very important and very interesting chapter, which is the chemistry in everyday life. So I'm sure you must be knowing that science, of course, what is science if not the application of it? Okay, these were the words of Albert Einstein actually. So science of today is technology of tomorrow. So all the science which we are learning through physics, through chemistry and biology, obviously they need to have their applications in daily life, or else there is no point in studying all this. So we have studied a basic idea of chemistry, the chemicals, and we have seen the metals and non-metals. And before that also we have seen physics. And in today's class, we shall be dealing in depth with their applications. There are a lot of chemicals, a lot of chemistry has many applications in our daily life. We shall deal with them in depth. Like for example, in the soaps and detergents, or aldehydes, ketones, or in the analgesics, in the antiseptics. Across all this, there are wide applications of chemistry. So let's deal with that in today's class. Any doubts regarding yesterday's class? I had told you to remember our important metals alloys, if you remember. Anyone? Have you finished reading the alloys? Yesterday I have asked you to please finish reading the alloys. All right. So I hope you've seen the alloys and I hope you've seen the ores and minerals also. They're very important from yesterday's class. So let's begin today's class, which is chemistry in everyday life. So first of all, before we begin our discussion, we should be knowing about soaps and detergents. Okay, what are soaps? What are detergents? So soaps, of course, they have become very famous during the COVID-19 time. Everyone has been focusing a lot on usage of soap and usage of sanitizers, hand washes, and so on. So for this, I'm expecting a question actually. I'm expecting a question on the action of soap. Because this is how questions are framed in competitive exams. From your daily life, from our awareness in everyday lives, questions are framed. So soaps are potassium or sodium salts of a carboxylic acid. Okay. So carboxylic acid, what is carboxylic acid? There is a long chain and at the end there is this group. This is your carboxylic acid. So soaps are the salts, potassium or sodium salts. So that means instead of the H, we have a salt. Okay, this becomes your soap. So it is potassium or sodium salt of carboxylic acid having a long aliphatic chain attached to it. And they are surfactants, which means they reduce the surface tension between a liquid and another substance, and they can be used in emulsification of oils and water. Okay. So soaps generally they are prepared via saponification of fats and oils, and the carboxylic end of the soap it is hydrophilic, whereas hydrocarbon tail it's hydrophobic. This is the most important part dealing with the action of soaps. So this end which we have, this let me show you the diagram of a soap. Okay, this is a diagram of a soap. As I told you, this is the salt of a carboxylic acid. So this end which we have, the ionic end, it is hydrophilic. That means it loves water. Okay, and the hydrophobic one, it is actually oleophilic. That means it loves the grease, it loves the fat, it loves the lipids. Okay, this idea you should be knowing properly. I mean, if you understand this, the COVID-19 and all how they're able to trap the COVID-19 particles, it will be clearer to you. Okay, see, this is one soap molecule. Okay, the whole carboxylic acid ka chain. So this aliphatic chain which we have, it is hydrophobic. This is water. Okay, all this is water. So in water, this ionic end which is there, it is waterphilic. So it loves water, it is near water. And this end, which is the aliphatic chain, it loves oil. It loves oil or fats, so it binds to the fats. For example, this is our famous COVID-19, which has completely caused the disaster in the world and has turned our lives upside down. So this is a structure. If you see the COVID-19, it has a spike glycoproteins, it has the RNA envelope inside it, but importantly, there is a lipid envelope here. This red one which you see, it is a lipid envelope. That means lipids are nothing but fats. Okay, so there is a fat envelope. So when we are washing with soap, when you're using a soap to wash your hands, the virus like coronavirus, it gets encased in that. It gets encased in the soap particles. Okay, these are the soap molecules. These are our soap molecules. As I told, this is polar, or basically the hydrophilic end, and this is the hydrophobic end. And these ends, see how they are encapsulating the soap, the dirt. Okay, they're encapsulating the dirt or the lipid of the coronavirus. It's encapsulating like this all around it. So the viruses like coronavirus or Ebola virus or Zika virus, all of them, they have a layer of fat called as lipid envelope. And the soap molecules, they're pin shaped with the water loving end and the oil loving end. So they'll encapsulate the virus, and that virus can be flown away from water, through water. Okay, this is the action of the soaps on coronavirus. Similarly, what do sanitizers do? The sanitizers also dissolve the lipid envelope. So they don't encapsulate it, they directly cut the lipid envelope. Okay, the alcohol tends to change the shape or denature the mushroom shaped protein structure. And this mushroom shaped protein structure, it helps the virus to bind to the human cell. This one. So alcohol particles, they'll directly kill this lipid envelope. Okay, and through this spike glycoproteins, the coronavirus actually enters our body. And since there are this gets destroyed by the alcohol, now it cannot, the alcohol based sanitizers, it cannot enter our body through this. Okay, this is the action of the soaps and the sanitizers on the COVID-19 virus. Okay, I hope this is clear to you. This is very important. All right, any doubts? Fine. And how do you make soap? The process of making soap is called as saponification. So a number of fats and oils, they're heated and they're mixed with a liquid alkali to produce soaps and water. Okay, which is the soap plus glycerine. Glycerine also is added to give that soft touch to the soap. So you can see here the triglycerides are there to that NaOH we are adding with the liquid alkali, basically NaOH, and it forms glycerol and the soap palmitate. See, so it has this big chain, this big carboxylic acid chain it has, and it has sodium. Okay, similarly you can see potassium. Potassium is added to this big chain. All right. So fats. So basically the triglycerides are nothing but fats. And this is there even since the 16th century. Since 16th century, they were taking the animal fats and they were heating and making this alkali, with the alkali to produce the soap and glycerine. Okay, this nothing much had changed actually since 16th century. Even now, we are taking the animal fats through all the Lux soap, Dettol soap, whatever we are having. Of course, in Dettol soap, there are antiseptic also added. But for the normal soap, this is the basic process. So since centuries, we are following this process itself. And there is something called as detergent also, which we use for washing our clothes. They are the potassium or sodium salts of a long alkyl chain ending with a sulfonate group. This is important. So they also have a long chain, alkyl chain, but they have a sulfonate group. Okay, you can see here the CH3 big CH group we have. At the end, instead of your carboxyl chain, we have a sulfonate group. Entire chain we have. At the end, you are having something like this. Okay, this is a sulfonate group which is there. And this solubility is attributed to the fact that the sulfonate group, it does not attach itself to the ions present in hard water. Okay, the sulfonate group which we have, it does not attach itself with the ions in the hard water. For example, in the hard water, we have the carbonates and bicarbonates of calcium and magnesium in hard water. But generally, if you use soap in the hard water, the group, the carboxyl group which we are having, it attaches with the ions. But the sulfonate group, because it's heavier, it does not attach with the ions in the hard water, and it tends to be separate. And common anionic detergents such as alkyl benzene sulfonates, they are used for domestic purposes. All your surf, Rin, Tide, all of these are detergents. They all have the sulfonate group. Okay, potassium and sodium salts ending with the sulfonate group. And what are the differences between soaps and detergents? Soaps, they have the CONA, as I told, with a long alkyl chain. The detergents, they have an SO3Na instead of a CONA. So they are not effective in hard water, but they are effective in hard water also, hard water and saline water. They are biodegradable, but the detergents containing a branched hydrocarbon, for example, here if you are having branching, here there is a branching, if you can see. To the CH, this chain, here it's branched. So if it's branched like this, then it becomes non-biodegradable. And the soap से जो जाग निकलता है ना, the scum, so they have a tendency to form scum in the hard water environment, but they don't form the scum even in the hard water environment. Not the jag, the scum, I don't know how you should say scum. For example, soap, if you use in hard water, it doesn't give you the jag. So it will just give you the dry, scaly sort of thing, which is scum. And they're derived from natural sources like vegetables, oils, animal fats, as I've told you. The detergents, they are synthetic derivatives. Soaps are environment friendly. They form a thick foam. This is the jag. Okay, and the thick foam, actually, if it gets diverted to the aquatic systems, it causes harm to the fish. It causes death to the fish and other aquatic life. Examples are your sodium palmitate, your sodium stearate. Here we have deoxycholic acid and sodium lauryl sulfate. Sodium lauryl sulfate is very famous detergent. Okay, I hope this understanding of detergents and soaps is clear to you. How they are working also we have seen. But mostly in our competitive exams, they focus on carboxylic acid group and the sulfonate group. This you should be remembering. So try to answer this question. Detergents are better than soaps because? Anyone? What should be the answer for this question? No answers? As we have discussed, the detergents are obviously better than soaps because they are not affected by the hard water, because the sulfonate group which is there, it doesn't form you ions with the carbonate and bicarbonates of calcium and magnesium. So they are less affected by the hard water. And they can be also used in your acidic solutions also, because sulfonate group hai, it is also acidic in condition, and in acidic solutions there are no adverse reactions. So the answer is both A and B. Okay, I think the answer was visible. Okay, I'm really sorry. Okay, now let's have a discussion on the halides of carbon. the major use of halides like of your organic chemistry are the halides actually, especially in the industrial and the chemical uses. For example, let us take the chloroform. Okay, chloroform, we have the trichloromethane, which is your CHCl3. So its major uses the production of freon refrigerant R22. On an industrial scale, it is used for making this refrigerants, chloroform. But in Bollywood and other movies, mostly chloroform is used. वो जो hanky पे डाल के chloroform डालते, so that it will give you an anesthetic feel. So that means you'll go into the deep sleep. Okay, it's a very general anesthetic in surgery. But now it has been replaced by less toxic, safer anesthetics like ether. Presently, if you go, for example, your dental treatment, if you go for a root canal treatment or extracting your wisdom tooth, they give you ether. Okay, it's a safe and less toxic anesthetic. And chronic chloroform exposure may cause damage to the liver and to the kidneys, and some people also develop sores on the skin when immersed in chloroform. And chloroform is slowly oxidized by air in the presence of light to form an extremely poisonous gas known as phosgene. Okay, and that's why it's stored in closed dark colored bottles so that air is completely filled out, because if chloroform it interacts with air, it forms phosgene. So that's why if you see a chloroform dabba, it's very kept in that dark environment, a dark colored opaque glasses it's kept. Similarly, iodoform. What is iodoform? Iodoform is your CHI3. Same, instead of your Cl, we should replace it with iodoform. Okay, and it is used as antiseptic, but the antiseptic properties, they are liberation of free iodine. This iodoform iodine which is there, this gets liberated. Even normal iodine particles also are very good antiseptic. So from this iodoform, you're getting iodine, which is good. And presently we are having other formulations containing iodine because it has an objectionable smell. Similarly, tetrachloromethane or CCl4, carbon tetrachloride. This is widely used in our industrial systems for refrigerants and propellants for aerosol cans. They're also used for synthesis of chlorofluorocarbons, other chemicals, pharmaceutical manufacturing, and general solvents. Okay, for what are chlorofluorocarbons? Like you have CF2, Cl2. Okay, any carbon based with fluorine, chlorine, these are your chlorofluorocarbons. And earlier they were used as cleaning fluids, both in industry and degreasing agent, and as spot remover and fire extinguisher. But the problem is it is toxic. If you inhale a lot of CCl4, your heartbeat can irregularly occur or stop, and even heart strokes can occur by CCl4. And of course, as you know, in the ozone layer depletion, CCl4 is one of the particle which damages your ozone layer. Okay, we have our ozone layer around the Earth's surface, and these are harmed by these chlorofluorocarbons, which actually, for example, this chlorofluorocarbon is there, CCl4. With the ozone level, this CCl4, it forms a chlorine monoxide, and this chlorine monoxide, it interacts with ozone to form you ClO and O2. So one ozone molecule is broken by these chlorofluorocarbons. So they are toxic, and by the depletion of ozone layer, we suffer from the exposure to UV rays, and it causes several skin conditions also. Right? Next we have freons. Freons are also similar to chlorofluorocarbons, and they are the chlorofluorocompounds of methane and ethane. So they're extremely stable, unreactive, non-toxic, non-corrosive. And the CCl2F2, it is the most commonly used freon. It is used for making tetrachloromethane by the Schwartz reaction. And it can be also used as aerosol propellants, refrigerants, and air conditioning systems. So widely for air conditioning, aerosol propellants, it's used. And these freons, they initiate radical chain reactions. As I showed you in the previous, these sort of reactions they can have, like the CCl2F2. it forms the CClF2 and Cl, and the Cl and O3 they form the ClO, and oxygen is produced. Okay, so ozone molecule is damaged. That is the depletion of ozone layer. Similarly, we have DDT. DDT is very useful as an insecticide. Since 1939, we have been using it. Paul Muller had discovered it, and it was very effective against mosquitoes and spread of malaria. So many species, but over the period of time, they develop resistance to DDT, and they have been discovered in a high toxicity in fish. Because the DDT, it's not metabolized very rapidly in the animals. It is stored in the fatty tissues of animals. Okay, so if there's a fish, it gets exposed to DDT, it is stored in the fatty tissue, and when human beings eat that fish, we are also affected by DDT poisoning. So that's why it was banned in 1973. Okay, this is a chemical structure of DDT. So those are our halides of carbon. Similarly, you should know in the chemistry about artificial sweetening agents, because in our daily lives we use sweetening agents like saccharin, which is orthosulfobenzamide. It is the first popular sweetening agent. It was discovered in 1879, very early, and it is 550 times as sweet as cane sugar. It is excreted by the body in urine unchanged, and it is entirely inert and harmless when taken. So that's why diabetic persons, they want that sweet taste, but they don't want, then they shouldn't be taking the calories. So they can use such artificial sweetening agents. Similarly, aspartame. Aspartame also, it is 100 times sweet as cane sugar. It is a methyl ester of dipeptide. Okay, formed from aspartic acid and phenylalanine. And this aspartame, it is limited to cold foods and soft drinks. Okay, because you can't heat it, aspartame. So only in colden conditions we should take the aspartame. And generally in the cold drinks, in Diet Coke and all, we use aspartame. Next, sucralose. It is a trichloro derivative of sucrose. It looks like sugar. It is stable at cooking temperature and there are no calories to it. Sucralose. Like your, I think, Sucrasmart. Sucrasmart is a sweetening agent. In those, sucralose itself is used. Similarly, alletane. It is a high potency sweetener. It is more stable than aspartame. That means you can use it for cooking, but you can't control its sweetness. If you add little alletane or a little more alletane, it severely increases the sweetening property. Now try to answer this question. Artificial sweetener which is stable only under cold condition is, I just discussed, this was asked in CAPF. So like these questions can be asked for the UPSC exams. Try to answer this question. What is the answer for this? Anyone? Nobody is interacting today in the class. Abhi, we just discussed a few slides back. We have aspartame. Aspartame, it is stable only under cold conditions. So you can't use it in cooking purposes. And it's a soft drinks like Diet Coke, Diet Soda and all. This aspartame is added. Next, let us see some antiseptics and disinfectants. So antiseptics, disinfectants, they are the chemicals which either kill or prevent the growth of microorganisms. So they are applied to living tissues such as wounds, cuts, ulcers, diseased skin surfaces. In such way, antiseptic effect is kept. The bacteria which is there in that wound, it's killed. Like for example, you have your Dettol. Dettol is chloroxylenol and terpineol bitheneol. Okay, these are the chemical names. You should remember it for Dettol: chloroxyniol and terpineol biethineol. So this gives it the antiseptic properties. And similarly, as we discussed previously, iodine. Iodine is a powerful antiseptic on wounds. Just 2 to 3% iodine in alcohol water mixture is called as tincture of iodine. Earlier, during the World War I, World War II times, this tincture of iodine was very famous. This, for example, soldiers when they got their hands cut, when they got the wounds in the war, tincture of iodine was prominently used. And this iodoform is also used as antiseptic. And boric acid also is very important. Okay, boric acid, your H3BO3. This is also very important as weak antiseptic for the eyes. Okay, it can be added if there's an eye infection. Doctors give you the boric acid solution, dilute solution. Similarly, disinfectants are the ones जो हम floor cleaners पे डालते हैं in the drainage systems on the instruments to clean them. So same substances which are antiseptic, they can also be used as disinfectant, but they are in higher concentration. Like 0.2% phenol, it is an antiseptic, while 1% is disinfectant in this way. Okay, and chlorine also 0.2 to 0.4 in aqueous, and sulfur dioxide in very low concentration, they are all disinfectants. Okay, so please remember these: phenol, chlorine, sulfur dioxide, all of these are your antiseptic and disinfectants, but they become disinfectants in higher concentration. Okay, try to answer this question. The mixture of chloroxylenol and, sorry, 1 second. Yeah, try to answer this question. The mixture of chloroxylenol and terpineol, what is it? Or how can we use it? Or you can please tell me what is the name of it? What is it called, this chemical? Okay, the answer is antiseptic. You must have seen the answer, and we are discussing antiseptics. That's antiseptic. This was asked in a competitive examination. That's why it's reproduced here. But what is the mixture actually called? Chloroxylenol and terpineol. Can somebody tell me in the comments the name of the compound which is formed? Anyone? We just discussed, yes, it is Dettol. Okay, this mixture is called as Dettol, and it is used as an antiseptic. Similarly, let us see some aldehydes, ketones, and carboxylic acids and their applications. So aldehydes, ketones, carboxylic acid, they're widely occurring in the plant and animal kingdom. What is your aldehydes? For example, aldehydes are this group. Okay, and ketones are your, both alkane chains are there to both sides of the CO group. Here we have COH. And carboxylic acids, as you're aware, is this RCOOH. Okay, COOH group is your carboxylic acids. So they are very important in the biochemical processes of life. They can be used as fragrance or flavor, like vanillin from vanilla beans, and salicyl aldehyde from meadowsweet, and cinnamaldehyde from cinnamon. So from natural vanilla beans, from natural meadowsweets, from natural cinnamon, you are chemically processing it to form the vanillin, salicylaldehyde, and cinnamaldehyde. And these reproduce the smell. The artificial vanilla which you get in the bottle, that you get from the vanilla beans itself, and you by the chemical process, the aldehyde is converted to aldehyde so that the fragrance is kept intact. And these families, they are manufactured for use as solvents like acetone, and for preparing materials like adhesives, paints, resins, perfumes, and all this also we can use this. And in the chemical industry, they are used as solvents, starting materials, and reagents. For example, formaldehyde, it is known as formalin. Okay, what is your formaldehyde? Your HCOH. Okay, it is used to preserve biological specimens and to prepare bakelite, for glues and other polymeric products. So this chapter, actually there is nothing much to teach for me. All of it you should remember it, you should memorize it. Okay, there is not much concept. Like aldehyde is where it is used, ketone where it is used, you have to memorize it. So by repeated readings you'll be able to remember all this. And this acetaldehyde, it is used primarily as starting material for acetic acid, ethyl acetate, vinyl acetate, polymers, and all of this. Acetaldehyde is your CH3COOH. Similarly, benzaldehyde. Benzaldehyde is used as perfumery and dye industries. And the acetone and ketones, they are like ethyl methyl ketone is your C2H5 here. Okay, this is your ethyl methyl ketone. So this is commonly used as solvents. Then methanoic acid, your basic methanoic acid. It is used in rubber, textile, dyeing, leather industries. Your ethanoic acid, which is your C2H5OH. It is used as solvent and as vinegar. Vinegar is nothing but your ethanoic acid diluted form. Similarly, hexanidioic acid is also called as adipic acid. Adipic acid, it is used in manufacture of nylon 66 ropes, so synthetic ropes. And here sodium benzoate is very important as a food preservative. Okay, so all these carboxylic acids or their sodium salts, they are very useful. All these applications we have in textile making, in your factories, in the industries, as solvents, as vinegar, and all these applications we are having. And the last part, we should be knowing some salts. So first important salt which we have is your sodium chloride or common salt. It is used in cooking food as well as for cooking gas, and it is used as preservative. For example, your pickles, agar pickle aap dekhoge, there are a lot of salt there so that the pickle ka particle doesn't get spoiled easily. So it is used as food preservative. It is used in curing meat and fish. It is used in manufacture of soaps, NaCl. It is used to melt the ice in winters in cold countries because NaCl, it raises the melting point of ice. So if you add it lowers the melting point of ice. So if you add salt at a point, ice won't be formed at that place. Water itself will be there. So if there are melting, in the Siberian countries or colder countries, salt is added because the melting point is lowered and the salt gets converted to water. And it is used for making chemicals like washing soda, baking soda. I'll show you them. Washing soda, baking soda. And similarly, sodium hydroxide, which is not a salt, which is your base, but it can be used for making soap and detergents. As I showed you in the beginning, for the soap making, in triglyceride and NaOH are added to make the soap, and they are used for making artificial textile fiber, rayons, making paper, and for purification of bauxite ore. They can be used for decreasing the metals, oil refining, making dyes and bleaches. For all this, it can be used. And in the degreasing, it is basically functioning as a soap itself. The sodium hydroxide. And bleaching powder, okay, it is your calcium hypochlorite. It is used as bleaching agent. It is calcium chloride kya hai? CaOCl2. CaOCl2. It is used in cotton industry, paper industry for bleaching the cotton and linen, and also for wood pulp industry. It can be used for disinfecting the drinking water. In chlorine, for in the sewage treatment, they add a lot of chlorine. And for example, if you see the swimming pools, in swimming pools they add chlorine because it will disinfect that water. They'll add bleaching powder. Sorry, they add bleaching powder to disinfect the water. And it is also used in production of chloroform. And it makes the wool unshrinkable. Okay, these points are very important, like which sodium salt lowers the melting point of ice, or which actually makes the wool unshrinkable. Bleaching powder, you should be knowing all this. But mostly it is used as a disinfectant and as for making in the industrial process chloroform. And that is about your baking bleaching powder. And now we have the washing soda. Washing soda is Na2CO3.10H2O. It is used as cleansing agent and it removes the permanent hardness in water. Okay, detergents are also useful in the hard water, but if you want to remove the hardness of water, in water we have two types of hardness. One is the carbonate hardness and non-carbonate hardness. Carbonate hardness is a temporary hardness which by just boiling it you can remove it. But non-carbonate hardness is more persistent. It has a strong bicarbonates of calcium and magnesium. So for that we use washing soda. It will remove the hardness. And ये नाम से ही आपको पता होना चाहिए, washing. So you're using for washing, so that means it is used for removing the hardness. And it's also used for manufacture of glass, soap, paper. Okay, and the last we have is plaster of Paris, which is the hemihydrate calcium sulfate. So CaSO4 dot half H2O. Okay, and if anybody has got a fractured, अगर school में कभी आपको fracture हुआ था, plaster of Paris लगाया होगा doctor ने. It is used in hospital for setting the fractured bone. And it is also used for making toys, decoration material, cheap ornaments, chalk and all. अगर you know for the Ganesh की मूर्ति जो बनता है during Ganesh Puja, Ganesh Utsav, or making Durga idols, Durga Puja idols, so that time they use the plaster of Paris. That's all made of plaster of Paris, this hemihydrate of calcium sulfate. And it's also used as fire-proofing material because it's actually a famous fire retardant. Okay, that is about the plaster of Paris. So that's it. These are the most important applications of chemistry. There are a lot of applications of chemistry, but these are the most important given in NCERT and which are asked commonly in our competitive exams. Okay, any doubt in this class or any doubt regarding preparation of chemistry, you can mail me on b.teja@gradeup.co. Okay, let's meet again on Monday for another class of chemistry. Today, as it's Friday and Saturday, Sunday are your weekends, we didn't want to burden you with too much heavy reading over the weekend. So this is a small chapter. Even in your revision, I think in 5-10 minutes you can cover it. If you listen this class carefully, then in 5 to 10 minutes you can cover it in the revision. So it's a small class, and from Monday again we'll begin our regular sort of tougher parts of science and technology. Okay, tougher parts in the sense we'll see more in depth of chemistry. Okay, so thank you so much, friends. Let's meet Monday 4 p.m. Bye.